All right, so first thing is a definition of the indeterminate form. So if the limit of f of x as x approaches c is 0, and the limit of g of x as x approaches 0 is 0, then the limit of f of x divided by g of x as x approaches c is said to be indeterminate, or more specifically, a 0 divided by 0 indeterminate form. Because remember, if we have 0 here and 0 here, that's going to give us 0 over 0. And so that's indeterminate. So we can't determine what it is because you're dividing by 0. And so the expression 0 over 0 does not represent a real number and should never be used as the value of a limit. So if a limit is a 0 over 0 indeterminate function, what we have to do is we have to do a further investigation, is basically required to determine whether a limit actually exists and define its value if it does exist, okay? So theorem 4 says the limit of a quotient. If the limit of f of x as x approaches c is equal to L, and L does not equal 0, and the limit of g of x as x approaches 0, c equals 0, then the limit of x approaches c of f of x over g of x does not exist. And so that's a key thing here, okay? So basically, if it's equal to 0 here, then it's not going to exist, okay? So what do we have here then? We have some examples. And so first to ask, is the limit expression a 0 over 0 indeterminate form? And then find the limit or explain why the limit doesn't exist. All right, so for A. So as x approaches 3, well, if we plug in 3 here, that's going to be not 0 in the denominator and not 0 in the numerator. So it's not in the 0 over 0 form. So that's the first thing it asks for. And so because of that, we can just use the rational theorem, and we can just plug in 3 into both of those. And so then the limit of x approaches 3 of x plus 1 over x plus 3 is just going to be 3 plus 1 over 3 plus 3, which is 4 over 6. And usually we reduce, so that's going to be 2 over 3. All right, what about the next one? So if we plug in 3 here, that's going to be 3 squared is 9 plus 9. That's not going to be 0. That'll be 0 in the numerator, but it's not the 0 over 0. So for B, it's not 0 over 0 form because that's what they're asking. They're not asking is it 0 over, you know, 18. It's asking if it's 0 over 0, and it's not that. And so basically, we can do the same thing we just did in this one. We can say, okay, well, now we're going to find the x approaches 3 of x minus 3 over x squared plus 9. So that's going to be 3 minus 3 over 3 squared plus 9, which is going to give us 0 over 18 or 0. All right, what about the next one? Well, if we plug in 3 here, well, yep, that's going to be 0. If we plug in 3 here, yep, that's going to be 0. So part C, yes, it's a 0 over 0 form. Okay, so what can we do to make it simplified? Well, remember, if we take that and do x plus 3 and x minus 3, that's the same thing as x squared plus 9. And then that's over x minus 3. Well, that's not absolute value, so that means we can cancel that with that. And now all we're really doing is we're finding the limit as x approaches 3 of x plus 3. Well, now that's back into being just a polynomial. And so we just take 3 plus 3, and that's equal to 6. And so that would be our value for the limit on that one. And again, that's what we have to do on these. We have to see if there's ways to reduce it or other things like that. So that's how we're going to have to work these types of problems. All right, so the last piece on this section is let the function f be defined in an open interval containing the number a. One of the most important limits in calculus is called the difference quotient, and that's what we're going to have here. As if the numerator equals 0, then this is an indeterminate form. So this is going to be our difference quotient. So that's going to be something we use quite a bit, and so kind of understanding what that is going to help us. So how do we use it? Well, find the following limit for f of x is equal to 7 minus 2x. And we're going to use 4 plus h minus f of 4 and all over h. And so what we're going to do is we have to plug all that into here. So we're going to say, oh, well, that's the limit as h approaches 0 of, and now we have all this stuff we have to do. So now 7 minus 2 times this piece, so that's going to be 7 minus 2 times 4 plus h. And then we have minus f of a, so minus, and we probably better put it in bracket there. And then that's going to be a 7 minus 2 times 4. And then that's going to be over, and then it's just going to be over h. Now we have to simplify. So we're going to distribute here, distribute there. So we're going to have 7 minus 8, and then it's going to be minus 2h. And then we'll have minus, because now we'll also distribute here. And so that's going to be a minus 7. That's going to be a minus 8 minus, so that's going to be plus 8. And then that's going to be over h, and that's the limit as h approaches 0. All right, so can we do anything? Well, 7 minus 7 is 0. 8 minus 8 is 0. Well, now, guess what? The h and h cancel. So now what we have is the limit as h approaches 0 of a negative 2. Well, remember, the limit of a constant is just a constant. And so that is our value. Okay. So this one worked out nice. We have a nice, value here, just a constant. And so we have that. But what we had to be able to do is we had to be able to plug in this value into here, and we have this piece. We had to plug in this value into here, and we have this piece. And then we still have just h on the bottom. And then we had to just simplify, and then after that, we get our final value. All right, so hopefully that helps you with 9.1.